So next up is Shicheng Liu. I always call him George, so I am not used to calling him by his writing name. Anyways, Shicheng is a third-year PhD student, and he came with a very strong systems background, and you can probably tell from this talk that there is this combination, both systems and AI at work here. Thank you.
Okay, thanks, Monica. So the talk I'm going to give today is called Answering Queries of Structured and Unstructured Data. So we kind of delved into this a little bit before with Sina and Yucheng, that there's big amount of text on the web and how do we make use of them. But in reality, there's also a different modality of data that are often very much useful for many different tasks. This could include more structured settings like knowledge graph, relational tables, and of course as well text. And as I think hopefully people have taken out of this talk so far is that for free text, techniques like WikiChat and RAG are very, very useful. But what do we do for structured data? What people have done is all kind of things, but our position for structured data is we should make use of query languages. And this is called semantic parsing in NLP, which is to say that for a question, we give that to some sort of language model, and that parses it into a SQL command and some sort of query language depending on the database. And we essentially run the SQL command against the database, and we gather answer at the end. So then there's a natural question of, okay, we can do free text, we can do structured data, but what do we do for things in between, right? So this is a database on Yelp, and you have these blue columns to the left, like name and cuisines and rating. They are more structured. You can think of ratings as numbers. These things are very structured. But then you also have this huge chunk of free text in these yellowish columns, like popular dishes and reviews. And the question is, how do we answer questions such as, can you recommend me an Italian restaurant with a romantic atmosphere? Where Italian has to come with the structure columns, but the yellow columns or the free text columns correspond to romantic atmosphere. Right? How do we do this combination? So what people have done in the past is, I'll give a brief overview of what people have done in the past. One very common approach is to say that I'm going to build some sort of classifier and just use one of the two. Right? But obviously, this is not going to work for things that require real combination, like the example we just saw. Another big part is, another thing that people have done, and this is actually very popular, as I understand, is to forego a lot of the structures and just turn the thing, each row of the database, into just one big chunk of text and hope an embedded model would work. But we found out through extensive experiment that this really doesn't work as well. Because embedding models are not really good at combining different predicates and especially handling numbers and comparisons and that kind of thing. So this gives me to our approach called SUQL, a conversational search over structured and unstructured data with large language models. And as Monica told us yesterday, this is also referred to as Stanford University query language. So the big promise of SUQL is we essentially add primitives into SQL, which is very popular for relational database operations. And these free text primitives are implemented with information retrieval and language models. So essentially, we know for structured data, people use SQL. For free text, people use retrievals and language models. And we like a combination. And a natural combination would be to provide these primitives into a query language. And these are the two functions we have. One is called answer, one is called summary. So for a similar question, I want a family-friendly restaurant in Palo Alto, you can see that the family-friendly part would directly translate to answer reviews, is it a family-friendly restaurant? And this can be operated on the free text. And location equal to Palo Alto, a traditional SQL concept on the structured data, is still retained. And you can have this intricate composition that just resolve this problem. So how to actually implement this compiler is actually very non-trivial. We can directly run these commands by a SQL compiler, but it is extremely slow and accurate. And details, I can't explain. I don't have the time to explain details, but just trust me on that. And we developed an optimizing SQL compiler to optimize the execution of all queries. And I'll just show two examples of why this is needed. One is suppose for the same example of answer reviews, is it a family-friendly restaurant? For most cases, you cannot afford to ask the question on all the database contents because that would be prohibitively expensive and takes very long for a question like this, where user is just looking for a few restaurants that return. So for applications such as recommendation, it is often not necessary to return all the answers. And we would use an embedding model or vector similarity to return the top candidates. And we will return the top results to LLM and ask it, okay, does it actually satisfy this? Another example are these things that refer to as predicate ordering. So for the same example, execution of structured predicates is much faster, right? Because it's just previously indexed and you compare the string against database contents. And that is much faster than doing the LLM calls. So we like to execute these structured predicates first before we move on to the unstructured part. But to build a compiler that handles all these things and to actually take into account of all the details that's possible and all the edge cases is really an important part of the project. Okay, so then we kind of evaluated the system on different tasks. And one of the very popular benchmark out there is called HybridQA, with hybrid in the name, so you know that it's a kind of hybrid data set. The big takeaway of this is that for the previous models, they were all trained on 62,000 examples. And those were the training set that they had. And we showed that our performance is, it outperforms other in-context learning models. So at the very bottom of this, the other rows are other in-context learning models. And we also showed this HPRO, which actually is based on writing Python code to try to solve the same problem. And we show that this is kind of 10%, at least 10% better than what they did. And this is within, you know, about 7.1% of the SOTA, the state-of-the-art, trained on many, many thousands of examples. And we actually showed that if you read the paper, this whole discussion on kind of the error analysis we found, and a big part of it was actually on kind of human annotators and the discrepancies between things like, you know, Boston, Massachusetts versus Boston. They're clearly the same thing, but these exact metrics don't work on those kind of things. So the takeaway is that I believe this is, with semantic parsing, this can solve this data set to a big extent. So we also built the same agent in the restaurant domain. The way that you can directly make use of this is you supply the schema and you supply a few short examples. And I'll go into a bit detail on kind of how you do the semantic parsing for more sophisticated data set later. And based on this translated SUQL query, you can then execute this against the compiler, and then you return answers. And we found that this is much better than a linearization approach I discussed earlier, which is to say that you try to linearize the system and then try to retrieve directly based on the chunks. We have a false negative rate, but combined with the benefit we get from accuracy or query precision, this is, we thought that this is pretty impressive. Okay, so those were the easy tables. What about real-world data sets? So this leads us naturally to a project that we did this autumn on how do we increase truthful reporting in journalism. And this is collaboration with my amazing collaborators at Big Local News and Cornell Tech and other members of the team. So this led us to the development of DataTalk, campaign finance agent, which the promise is to be able to chat with public available campaign finance data from FTC and some data from Open Secrets. So the DataTalk campaign finance data set is huge. It's based on Federal Election Commission. It's based on open elections. And this contains 36 large relational tables. So the Yelp data set, even though it's still real life, people still use Yelp, it is a much smaller and much more consumer-focused domain compared to kind of this expert domain that require kind of real computations and stuff. Right? If you think about it in Yelp, nobody really cares about, like, I'm going to aggregate all kind of restaurants together unless you're doing some sort of restaurant consulting, I suppose. But for this DataTalk campaign finance, it's really important to be able to handle those, how do we aggregate things? How do we deal with rankings? How do we deal with group buys and those kind of things? So we kind of spent a long time trying to figure out what a good solution to this. And we thought the good way to start at the end was to model how a human expert write a knowledge query. And this is also a lot of work by Sina, who gave an amazing talk just earlier. So we like to start by writing simple SQL or SPARQL queries. So SPARQL is the query language on Graph, which I'm going to talk about later. And second, you like to look up details of how the knowledge base is constructed. Okay? To understand the structure of the knowledge base, such as the relevant tables or entities in the graph, or properties in the graph. And then you like to add new SQL or SPARQL clause to build towards the final SQL and SPARQL to be able to answer this. And I'll show you in a bit why this is kind of really necessary to, like, as opposed to trying to do everything in a single step. So this whole process weaved together a big part, which is knowledge inquiry. So large language models do not really have access to these data, right? It's possible that some of the FEC data are trained, but it definitely does not have detailed knowledge of how each column is at the present time in the database. So a big part of it is to first understand what is in the database to begin with, and how do I make use of the data in the database. So this procedure weaves together knowledge inquiry together with query writing, which is essential for answering questions, and it also weaves together execution, evaluation of results. And we see this in action in a little bit. So this leads us to our approach, which is an agentic approach for knowledge bases. When a user query comes in, we give that to the agent. The agent thinks and issues actions, and then it observes results. And this dynamic updates the loop that constantly changes its understanding of the database. And that finally leads to agent response. And the action you can take include these things that I'm going to talk a little bit here. So what we found useful for writing SQL are the following commands of, we like to get tables, retrieve a short description of all the tables. We like to retrieve table details of individual part of the tables. We like to execute SQL and get the results. We like to also perform entity linking. For instance, if you have a question, if I'm searching for Donald Trump or Kamala Harris in this database, you'd like to be able to match that against one particular ID. We'd also like to perform location linking. This isn't too much on FEC, but we found this useful for some other projects we have, because you like to be able to translate location to, if there are coordinates in the system, and location is a big part people often have to deal with. So we built this system, and we did a real-world experience with journalists that I think Cheryl gave a good overview yesterday. Here are some examples of the papers we were able to publish, or stories we were able to publish. And this is, I like to emphasize, is number one lesson we learned out of this exercise or experiment is that interpretation of results are difficult, and you often like to need to capture expertise, just like in printers. We had to, so we spent a long time developing the system, but we spent even longer time trying to really make it useful by real journalists. And that's because there's so many nuances that exist in a data set that you cannot just simply rely on a language model to know them. So a good example is like, there's lots of caveats. A good example is that contributions below 200 are not included in some tables. And this is a big problem because when you add up the individual contributions, it sometimes doesn't add to the summary statistics that SEC provides you. Right? It's these things that journalists need to know about so they can trust the system better. And if they know about that, then they can really make use of that. But if they don't, they'll have big problems with trying to understand, make sense of data. So this part of capturing expertise is really an interesting part of this project. And for that, we work with a campaign finance expert, Derek Willis, and he provided a lot of expertise on how do we deal with these. And we kind of incorporated some of that into this agent. There's still ongoing work that we have to try to kind of generalize the system to other domains. Okay, so I was told that it works now. We had some quota problem earlier on the chat, but I can show a quick example of kind of how this really looks like. So basically, if you issue a question like, what are the top 10 packs focused on crypto, ordered by the amount of money raised, you can see that the agent takes a list of actions in its thinking to try to understand the database. So we first issue kind of these two questions, these get table details asked, then you will write some query. Then you will realize that this is a problem with kind of how it quotes the system. Okay. And then at the end, it kind of takes a few tries to write the correct queries. Then at the end, you realize that, okay, I need to fetch the table a little bit more to understand what's really going on. And it will write this query at the end to fulfill this request. And you can see that some of these things that it does, so like some of these are instructed to be able to do this table join to begin with, because whether I need this join is unclear to begin with. Okay. So at the end, it would write this SQL. It will give you explanation of the SQL. This is helpful for journalists. Also from an educational perspective, they want to understand what's really going on. And this will give you a limitation of database what it thinks could go wrong with this query. And then it gives you a result. Right? These are actually linked to the FEC side if you want to investigate. And then we had this site that I think Cheryl showed yesterday on kind of how do you, you can share queries, you can make sense of the queries, you can increase the limit, you can disseminate the information better. And then it gives you kind of follow-up questions that you can answer, you can ask. And we found this part also particularly interesting is we found a lot of people kind of just clicking through these actions and trying to understand what's really in the database. And that kind of links to what I'm going to talk about at the end of the talk on some of the ongoing research we have. All right, so that is kind of on relational tables, and we had this kind of real life experience with them and what we found out about them. And there's another big chunk. If you remember at the beginning, I kind of showed three different pictures or graphs. One of them is a knowledge graph, right? I talked about relational tables, and there's also a big part of knowledge of structured data incorporated as knowledge graphs. So knowledge graphs are these things sometimes known as semantic web, and they have nodes as entities and edges as relationship. Right? So this kind of showcases what's going on with a subpart of a Wikipedia, a selected subset of Wikipedia articles and their nodes. Wikidata is one of the very interesting knowledge graph because it's super large. So here are some stats we have on this database. And all entities in Wikipedia are actually in Wikidata. So you can find them in Wikidata as well. And a lot of things that you see on Wikipedia are linked to Wikidata in some way, like the population in Palo Alto in previous years. Right? And Wikidata contains many more entities than Wikipedia actually for you to be able to make sense of the data and deal with many things. So the question now is how do we combine the best, how do we do the same thing we did with relational databases and do the same with knowledge graph, which is to build up a knowledge interface for it. So the key idea for this is kind of similar to what I talked about before, is we like to combine the ability for you to write queries together with understanding database. So graph retrieval would be kind of a way that you think about, I like to examine the actual properties in the data. And our approach is that for LLM, we like to automate the human expert approach of writing queries and understanding database. The humans don't really memorize the nodes and properties. So neither do LLM have to do the same thing. They can look them up when they need it, right? You like to understand the database when necessary. So here is another set of actions we used for graph databases. And these include searching Wikidata for the relevant QIDs and PIDs, which are the entity IDs you have in the graph. You can then get Wikidata entry, which is translating a QID into a Wikidata page for an entity. You can get examples of the properties. And this is actually surprisingly important because a lot of times you have different properties that represent the same concept or a similar concept. And there's slight differences in how you use them, like time or location. Location is not a good example. You have things like located in administrative territory, you have things in country, you have things in a province, that kind of thing. And you like to understand when you like to use specific concepts. So looking at examples, we found that to be also very helpful. And then you like to execute SPARQL to query the results. So this kind of leads us to, for the two agents I talk about, the two different set of actions to be able to fetch data from these knowledge bases. So this work, we built this agent and we called it SPINACH with my amazing collaborator Sina, who came up with this name. I think it will be, so for those of you who don't understand how CS people like to do is you make an acronym, you take each part of the, oftentimes people take abbreviations, and what they do is they take each part, the first letter of each of the word and combine them. Okay. So to be able to find something like this is difficult, to say at least. And here is a real-time example of kind of how this looked like. Monica, I think, briefly showed this example as well yesterday. So suppose you have this question, and you like to first understand, so the question is what are musical instruments played by people who are affiliated with the University of Washington School of Music and have been educated at the University of Washington, and how many people play each instrument? So you see that LLM first think a little bit, as we saw in the demo just with FEC. First, I need to identify the properties and entities, and I would search this. And I will find some observation, in this case, this particular school that's of interest. Then we will search Wikidata for the relevant PID, musical instrument. And then it will construct some queries. And it finds out a problem because it somehow hallucinated an entity in the middle. And then that led to the SPARQL giving no results. Well, so how does it fix it? Tries to deal with it one step at a time. Tries to find all the entities along the query and try to figure out what's going on. So then you took a look at this, and this is a city in Russia. Looks like nothing was what we were dealing before. So it actually issues another query to find the actual entity, not the hallucinated one, and to be able to use that in future constructions. At the end, it writes this SPARQL that makes use of a concept like group by to be able to give you this report. So we profiled how this works on different data sets. We profiled this on previous data sets as well as the new data set we constructed. On previous data set, it beats all the other system we had out there on Wikidata. The only one it didn't beat was the WikiSP fine-tuned on the same data set. And again, this leads to all the annotation problem we kind of saw earlier. And the fine-tuned model is able to understand some of the these useless things in the data set in a sense. We also constructed this new data set, also called SPINACH. And we compared it with some of the very, like the same baseline WikiSP I showed earlier. And we showed that this fine-tuned model doesn't really generalize as well as what LLM model can do on this data set. There's also a very interesting comparison to be made with some other approaches on how do you ask LLM to walk the graph. So as opposed to using queries, another big approach is I try to look at the graph by walking it. And I have actions where you kind of can take one step at a time to try to walk the graph. And we found out that these are not really good because they don't have the enough construct query language have to provide the same functionality. And this showed us state-of-the-art called TOG on the last row before SPINACH. We showed that it drastically underperformed what we were able to do on this new data set we constructed. So this data set is on real-life queries that we collected through the Wikidata query forum, which are quorums where people discuss how to write these queries. And the example I showed earlier was actually one of the queries. And yeah, so this is kind of really outperformed previous tasks. So we also deployed this on Wikidata forum, and we have we have currently over 1,700 conversations in the wild. There are people actually from across the world using it. As we look through the log of people using them, there are different languages. Most of them I don't recognize, but LLM can recognize and can respond in their languages as well. And this is actively growing. We still have people using it to write queries every day to be used for things that they care about. We have, we did this analysis, one of my amazing collaborator, Hao, sitting over there, who contributed a lot, and one of the contributions was this particular experiment we did, and we selected about 200 conversations, and we found that the success rate is about 78%, and that's higher than what I presented before. And because that data set kind of contains really hard questions, and for these kind of simpler questions, we had a higher success rate in practice. And some of the next steps could include, can we fine-tune an open source model to do the same job? How do we include expert knowledge, as I was discussing earlier with the FEC data? And how do we use potentially more exhaustive tree search methods as opposed to kind of how do we just do it linearly, right? Those are some all interesting directions we were hoping to explore. Okay, so with that kind of presented to a few lines of research that I had. I'd like to give a preview of our ongoing research. So this project is about how do you do knowledge curation across dataset and internet. And so we have DataTalk over here, right? We have Storm that Yicheng presented earlier. And the question is, how do we combine them together and give your children called Data Storm? So the idea is that for Storm, it does a very wonderful job of writing an article. And Yicheng has talked about how many people have used it. And here, example of a summary of just the beginning of the article that Storm can write with real-time citations, right? But sometimes you like to, maybe you have a data set that you really care about, and you like to integrate that with structured numbers to understand what's going on, right? And this data set in particular is from ACLED, We had the CEO presenting a forum yesterday, and ACLED contains a lot of real-time and really nicely crafted database with different entries of data sets of conflicts in the world. And for this one, you like maybe a section on kind of how are the recent developments according to ACLED, and how are some statistics with respect to different countries, right? And you can see here that the agent would ideally the outcome of data storm is to be able to ask these questions and combine them and write a report for you in this setting. Okay. You can see that here 2 of the tables he does. And the table is actually from DataTalk, right? This is the same table you had on the average fertilities over there, together with, this is the same table as we had here, right? And the idea is you can click on this to see a detailed report of what the database actually did, okay? So that people can understand the combination better. And you can still do the same thing as we did in DataTalk. People can look through the SQL to see if there's any problem with the SQL. They can potentially use idea from CoStorm, try to combine them together. And that, I think, will be really, really useful for investigative journalists or just people trying to understand the database and try to make sense of it. As opposed to kind of clicking through the suggested queries I showed earlier, you can do a very good job. This can hopefully get you a better ground. You can start off with a really nicer understanding of the database, and you can ask more interesting questions going on later. So how do we use DataTalk right now? We have a few options. Option 1 is you can supply a schema declaration and just a database endpoint. This is an ongoing research we had with ACLED, and we can provide you that service. Right? Second option is you can supply schema declaration and a bunch of raw CSVs you have. This can be as big as you want. And if you want to be hosted, you can contact us. Option 3 is open source software, and you can go to our GitHub page for see all these different projects we have. Okay, I think that's everything I have right now. And I'm happy to take any questions at the break. And I think we can have a few questions if anybody has anything right now. Yep.
This is very simple. What's the site that combines the two? DataStorm? Is there a...
That's still a preview.
That's my use case.
Right. Good to hear that. We are working very hard to try to make that happen. Yep.
So, could you get to the mic, please?
It's something I've been meaning to ask you about. So you mentioned the schema. What does that look like in practice? Are you kind of listing the tables, the names, the columns, but then more heavily describing what each field is? Because sometimes, especially FEC data, these are pretty arcane column names. Like, can you talk a little bit about what that process looks like?
Right. So that ingestion process, we are documenting all the procedures you need to have it. But the basic idea is you like to supply a list of tables. Sometimes I don't think it shows here because how big it is, right? But so basically you supply a list of tables together with each of the fields. And if you have any annotation for the field, that would make it much better. Because if you have a table that's just named column ABC, I have no idea what's going on, right? But so you like to provide some annotations with them. So essentially for each table with different fields, how does it look like? And some other kind of engineering related things, like how do I find it, what's the endpoint, right? But we're documenting it and hoping to be able to make it available very soon. Yep.
So I see that you have data commons in there, which is another massive knowledge graph. We work a lot with them, and I'm wondering about the Wikidata knowledge graph. And are you able to combine kind of these sources, like, because the Wikidata one will be a lot more concepts and facts and whatever, and then the data commons one will be quite focused on hard data points.
Right.
Are you able in some way to connect? And I suppose a related question would be, when you're describing the ACLED work with the API endpoint, does that mean that you can potentially not just work with knowledge graphs and SQL tables, but just understand the schema, the specification of the API, and just use that as opposed to try to write SQL queries or SPARQL queries? Right.
So the first question, as far as I understand, Data Commons does a lot of job with linking with Wikidata itself as well. So I think all the nodes have
the properties
data
they're
IDs.
they're matched, right? In
Yeah,
the
yeah,
background.
yeah.
It's just not
So-
the same data in the background.
Oh, okay, okay. That's interesting to know. I think we're still actively kind of working on setting up data commons. They have a slightly different graph database in a sense, and we're trying to make sense of that. And
We should talk.
how do we make the agent? And we can talk later on the details. To the second question, so I suppose option one is trying to say that as opposed to kind of giving the database content all to us, you can just provide an endpoint and we're able to tap into it. But at the end, we're still writing SQL to be able to fetch it. It's just a matter of, the hosting is not done by us.
So in that case, you would pull the data, create a table, and then query it yourself in the background?
Yeah, well, we don't create the table. We call the endpoint for SQL commands. This is
Right.
what we did with
With the actual data, okay.
Yeah.
I see.
Yeah.
Interesting, thank you.
Yep.
Just one question over here. You talked about schemas. Does that also include the aspect of data catalogs or lineage that could get more enrichment to drive the declarations here?
Could you give example of what a data catalog looks like?
Data catalog could be metadata that's tied to the tables that exist.
Right.
Lineage could be where an aggregate is pulled for, where's the data source, and what's the connection between an aggregation, a KPI versus the original data.
Yes, yes. So that kind of ties into Sador's question on annotation, and yes. So those are included right now as kind of comments in the create table commands.
Got it.
But they are very important, right? Because they're kind of the same thing as what the column means, what the table means in a sense. So yes, they are very important. Thank you.
Thanks, George. Georgie here. So thank you. It's a wonderful
Thank you for having
presentation. You gave me a lot of things to think about. So in my previous life, pre-Stanford life, I was part of the ICIJ, which did Panama Papers and projects like that. There's a massive data on corporate structures and all of that. So I'm just wondering, are you? I see that you're looking for people interested in hosting the agent, but are you looking for more examples? And would this be something
Yes.
like interesting? Because it's based on the leaked data around the world about oligarchs and tax havens, and I think that would be a great example for a data
Right.
storm.
So I know I'm running out of time, so I'll say one word, yes.
Okay, so we should
And
talk. Okay.
contact us and we
All
can
right,
talk later.
All right, we'll talk later.
I mean, we are talking to data comments, and they have trillions of data points. So yes, there are lots of data out there, and we will see what we can do.
Journalists, you were talking about journalists as an example. This would be a global, international community of journalists.
Yes, there are. Yes, I'm just saying that Data Commons is an example where they collect data from everywhere and they work for United Nations and stuff. So we have that. We have that. We would like to, but it is kind of limited in how much we can do. But we just want to show you something that you can do for yourself. All right. So for the last talk here, last but not least.
Can I just add one thing, and that is that this is all open source, right? So we can
Yes.
build on top of what you are.
We need
you
your
are
help.
doing. Right. Yeah.
We need your help. So for the last talk.
So does that mean that, like, for example, ICAJ could use this as an open source? Are we talking about that? Is that, Cheryl, what
It's
you're
open
saying?
source. You can be part. You can do the work. We can host it. You can host it.
If you
Anybody can host it on the local
okay,
machines.
Cheryl and I'll talk.
I mean, we would like to point to you, and you host whole bunch of things, and you can use our open source software. We want to connect to everybody's projects because we don't have enough manpower.